Let's have a look at biogeography as another strand of evidence for evolution. So biogeography is the study of plant and animal distribution and how it's related to geography, of course. And we'll start by explaining the idea that, of course, due to plate tectonics, that at some time in the past all the continents of the world were much closer together. In fact, many were joined into a world supercontinent referred to as Pangaea. And then over time, these continents floating on the tectonic plates on the Earth's crust have slowly floated apart, have moved apart, to form, first of all, a northern supercontinent called Eurasia, and then a southern supercontinent called Gondwanaland. And then, of course, over time, these continents have moved further and further apart to the place where they are today. Now, this helps us to understand also how different species that we observe today, or different fossils even, could be widely distributed across different parts of the planet when clearly they're all related to some common ancestor. So we ask the question, how could that be? And perhaps the best theory is that at some time in the past, some of these species, many of these species, were related to a common ancestor found in one particular part of the world. Say, for example, here, and at the time, some of those that species will have distributed itself across related continents, and that today we find either fossils of those species now widely separated on different continents, or we even find descendants of those species. So the basis behind biogeography can be outlined in these 3 points here. First of all, that closely related animals in different geographic areas probably once had no barrier to dispersal in the past. So by that they mean that there was no barriers like the ocean or the sea, or in some cases mountains even, and that they could freely move across continents to different areas and so dispersed. Secondly, the most effective barrier to dispersal now in land animals is the sea. So as sea levels rose, or as continents moved apart, then the ocean has formed barriers between these continents. And the third point, that the discontinuous distribution of modern species, that is, that modern species are located in very different places and don't interbreed and don't mix, could be explained by movement out of the area that they were originally in, before the continents had moved apart, or they could well have been found in a number of other places but no longer are there because they've become extinct. So if you take the common example of the flightless birds, the ratites, which today you have the species of the emu, found only in Australia, the ostrich, found only in Africa. You've got the cassowary, found only in Papua New Guinea, and the kiwi, found in New Zealand. It's pretty clear that these birds are genetically related and morphologically related. They look very similar, yet they also have their differences, and it would be suggested that at some time in the past they all came or evolved from a common ancestor. But why are they now distributed across continents like Africa, Australia, New Zealand, New Guinea, when clearly they couldn't have done that, in modern times? And it would be suggested that at some point in the past, when those continents were much closer, that the common ancestor distributed itself across these various continents, and then that common ancestor, found in these different places, then diverged from each other over time due to different pressures to do with natural selection. So they've all become slightly different and have evolved into separate species. And this can be explained by this notion of biogeography. Let's have a look at examples of various species found in fossil evidence today. So fossils of Cyanonagnthus here can be found today across Africa and South America. The only way to explain that fossil distribution is that in the past that animal could have freely moved between those continents when it was closer together. Likewise, Mesosaurus, Also, the fossil of the fern Glossopteris is now found distributed right across South America, Africa, Antarctica and Australia. And again, the only way that could perhaps be the case is that once that fossil was able to easily be dispersed when it was living across those continents when they were much closer. And likewise, Lystrosaurus. So this seems to be strong evidence. Biogeography can supply this evidence that in the far past, when these continents were closer together, that the common ancestors or the ancestors of these animals, or even these fossils in this case, were able to easily move, and therefore can be found in a wide distribution today. Species that are found today only in one continent, like for example the emu in Australia, these species are described as endemic. That is, they're only found in one particular continent. Whereas if you go back in the past, the ancestor to the emu and the ostrich and so on may well have been able to move freely across a number of continents. But today, because of barriers like the ocean, etc., these species are only found in one place, and that makes them endemic. We'll finish off the tutorial by you might want to pause the tutorial and just have a look at this example of the biogeography of the camel family.